All right, great. Hey, listen, welcome back, everybody, back to another Zoom meeting with the Sandoval crew. Now, let me go ahead and share my screen. We got Celeste, Max, Marcus. Thank you. All right, good. Hey, listen, let me share the screen. So here, all right, hey, listen, today we're actually going to look at graphs and look at quantitative data. And remember, with quantitative data, this is data that we could actually measure. Okay, so with that, Celeste, why don't you go ahead and read this first part of the sentence here.
A class of students were asked to track how many hours a week they spent on schoolwork during distance learning. The results were as follows.
Okay, good. Marcus, read out the numbers.
20, 26, 28, 27, 25, 28, 45, 40, 35, 32, 38, 36, 35, 37, 32, 28, 30, 32, 35, 38, 28, 32, 29, and 38.
All right, good. Hey, listen, did any of you kids get to these numbers of Zoom hours per week?
I have no idea.
Yeah, I know, right? You know, they were asked to track, and it would be an interesting experiment if we tried it on our own. You know, like if we saw how many hours we actually do spend on Zoom. Now, with that, Max, go ahead and read this vertical bar chart. Or tell me. Okay, look at the vertical bar, like just say the vertical bar chart.
So the first graph is about 20 hours.
Okay.
And the third one, yeah, well, yada yada. I think you get the gist.
Possibly, right? Marcus, can you share more about this vertical bar chart? What do you think is it trying to explain? And let me try and go back to the data.
What is it trying to explain?
Yeah.
The amount of people who had each amount of hours or something?
Yeah, and really what it's trying to do, if anything, it's giving you like an order of persons. Like if you notice this, you see how it says the first person and it says 20? And then if you look at it, it's not in here. So let me write it in. And this is the things that sometimes happen with this. You see how the second person says it's 26? So it's basically all these data that we have here, just in ordered form. Does it make sense? They just put it down. Okay, the first person said 20. Second person said 26. The third person, let's watch for a second, said 28, right?
Mm-hmm.
The fourth person said 27, right? And so on, so on, so on, right? So kind of interesting, right? Okay, good. Now, Marcus, tell me what's the difference on the one on the right?
It's horizontal.
It's horizontal, right? And what's something else that you notice that is unique, new to it?
I don't know.
Well, you're right about horizontal, but does the data look the same?
Yeah.
Yeah, it does. What's going on, Celeste?
I've been raising my hand. The difference is that there will be fives between them. Like it will be 0, 5, 10.
Well, the data doesn't change, but the appearance does. Do you notice that?
Yeah, the
Yeah.
hours are.
Yeah, because look, the first person is still doing 20, just like here. Hold on. You see that?
Mm-hmm.
So the data is the same. Like you were absolutely right, Marcus. Your result was good, and you were quick to pick that up. It's exactly the same. I could guarantee you that the 38th person, this is the 23rd person, which is this one right here, he's at 38 hours. And the same thing here, 23rd, 38. So as a result, you come to see that they're the same graphs, but because of their presentation, they sometimes may be construed as different. So this is where it's important that you know how to interpret these things. When you're shown these things, that not just be taken off and just say, oh yeah, that's it. Does that make sense? Yeah.
Yes.
Questions for me? No? Okay, good. Then let's go ahead and go to the next one. So okay, here you go. All right, now here's some questions in regards to these. And it says, when we ask about the range set, okay? Okay, or actually, Celeste, why don't you read what it says here?
When we ask for the range of a set of data, we can mean two different things.
Okay, so Max, what are those two different things?
The minimum and the maximum values of that set.
Okay,
In this case, from 20 to 45.
all
And
right.
number two, the difference between these values. In this case, example, 45 minus 20 equals 25.
Okay, so Marcus, what does that mean to you, this 25?
That one kid practiced 25 more hours than the other.
Yeah, exactly. That's what it means by the range. Range means that you kind of get an idea of difference between the highest to lowest. And so you're right. You're absolutely right, Marcus, that there was a kid that did 25 hours more per week than another kid. Okay, so let's read the next thing on here. It says, when we ask.
When we ask what the normal amount of time is for a student in this class work on schoolwork, we can come up with different answers depending on how we look at it. Look at this data and write down what you think the normal amount of time these students worked on schoolwork each week.
Okay, good. So Marcus, what would you tell me? Describe what you chose as an amount to write
As
down.
an amount?
Yeah.
Well, I'd probably just put 32
And why 32?
because that seems to be the mode.
Oh, because of the mode? Oh, cool. And why did you not use mean, median, or one of the other ones?
Because that's way too hard.
Okay, so the easiest one for you was a mode. Now, I think that that's actually kind of interesting because what would be the average of the range between 45 to 20?
Well, if we just had those two numbers, it would be 32. Yeah, 32.5.
32.5, right? Yeah, so in the case, you're actually pretty right. The mode was a good way to go with it. And then we did an average of the range. And actually, this was a very skewed because if there was something on there, it really could throw this number off. Does it make sense? Like sometimes that's the reason where you got to actually take the average of the actual numbers. Okay, good. Okay, now let's go ahead and scroll down and go to the next page. That's where we're at. All right, good. Okay, so now Celeste, read the first sentence.
Okay, having the data in numerical sequence helps when you are looking at data like this.
Okay, so Max, go ahead and read the sequence.
You can also use what is called a stem.
Oh, no. Read the data again.
20, 25, 26, 27, 28, 28, 28, 29, 30, 32, 32, 35, 35, 35, 36, 37, 38, 38, 38, 40, 45.
Oh, cool. All right, neat. Now, Marcus, read the next part.
Okay. You can also use what is called a stem and leaf plot to organize the data.
Okay. So what do you notice on the stem and leaf plot?
It has the tens digit on one side and the one digit on the other.
Yes, exactly. Yeah, so you look at it, and actually I would think for the most part, this is a good thing when you have a lot of data or when you want to like if you're used to using this, okay, I would say, yeah, absolutely use it. Does it make sense? Stem and leaf is really, really cool. Because if you discover, Marcus, where do you know that most of the data is located at? And which of the tens digit?
3.
Yeah, in the threes, right? All this right here is where you have the most of the data. So that gives you an idea of something that is important to us that we've been learning about, which is central tendency. Our central tendency in this case, in this data, is here. How do we discover it? Well, because if you notice stem and leaf, they kind of led us that way. You really can't see that up here unless you could see it now. You see how maybe that's the biggest chunk or the biggest piece? as opposed to, let's say I color coded these. Okay. You would notice that the yellow one's the biggest. That's where the central tendency tends to be at. In this case, at least for this data. Okay. All right. So now let's look at these. And so let's say, tell me what you see on the left.
What I see on the left is a dot plot.
A dot plot, right? Okay, good. And what do you notice about the dot plot? What can you describe to me about it?
I can see that there's one dot above the 20, then one dot above the 24 and 26, which means that it's
Okay.
a 25.
Okay, now why is there 4 dots above the 28?
Because it repeats itself.
Yeah, it's like showing you that there was 4 people that were on 28, right? Okay, good.
Mhm.
So Marcus, were you correct as far as your mode?
Well, kind of, because there's 2 modes,
There
actually.
was 2 modes, you're right. Yes, and I agree with you. Okay, good. All right, so you could get a dot plot, and that also helps you. Notice how this one's different. It's the same data, but do you notice how it's different from the other ones as well?
It's a bar graph.
Yeah, well, no, it's kind of like a bar graph. Actually, the bar chart is the one on the right. This is a dot plot. They're just putting dots. And it's kind of like, when you play Connect Four and you're putting the stuff down, it's just like telling you, okay, how many in these, how many in these, how many in these. Like this one tells me 4 people to pick 28. Hold on, go about writing mode. 4 people pick 20. Ooh, let me actually get into the pen. Yeah, 4 people pick 28, 4 here, 3 here, 3 here. Does it make sense?
Mm-hmm.
Okay. All right, good. Okay, now, Max, why don't you read the next one? Or actually, Marcus, since you brought up the bar chart, what do you notice about the bar chart?
It's like the dot plot, but sticks.
Yeah, well, where's the 4 located?
The
See how-
bar, it's located on the side.
Yeah, exactly. So it looks a little different. You
has
sometimes are able to see. Now remember, keep in mind, this is the same exact data. There's nothing new from the first ones we saw to now. Okay, so this is something that's kind of interesting because now you're looking at data in different representations. Okay, and now check this out. All right, Max. Okay, you see this right here, this thing? What is the next one?
Next one seems to be a histogram.
Yeah, it's a histogram, right? Okay. Now look at it, and what is it that you notice that's different about it?
It looks like an H. Oh no, my bad.
Well, you're right about that, but give me something different. Give me something other than an H looking. And
It
anybody
shows a frequency.
Yeah, so what does frequency mean exactly?
Like the repetition of why that keeps showing up or something similar like that.
So now let me ask you this, and this might be a better interpretation, okay? You know how you get graded on numerical grades, right? So what's an A?
An A is 91 to 99.
Well, isn't it from 90 to 99? Or 100?
It's an A minus.
Isn't it like that? 90 to
I got it.
Right? That's an A, correct? Okay, good.
Mhm.
Now, imagine that a histogram is like, okay, well, how many kids fell into this 90 to 90 something? Like in this case, okay, you know how we said that 28 showed up 4 times, right? Like if I go back to the data set and I want to see what numbers were between 25 to 30, I'm going to be able to guarantee you, let's see, this is 7, 8, that there should be 8 numbers to actually fit in between 25 to 30. It's kind of like the grade, you know how, like, let's say there was a test that was given, okay, and you wanted to know how many students scored an A, okay? Like imagine that being over here. Marcus, give me a number. How many students scored an A?
32.
32. Okay, so it would be like way over here. Your bar graph would be 32 students. Does that make sense? So that's what a histogram does a little differently. Is that in between that range, it'll tell you, okay, inside this range, will tell you how many there are in there. Okay, so that's why a histogram is kind of interesting in the way it's collected. Okay, so now, so that's kind of like a brief introduction to a histogram. Let's go into box and whisker plot. Okay, This is probably very new to you guys, but what can you notice about a box and whisker plot?
You got a line?
Yeah, you see this part right here? What is this?
That is the end of a line.
That's the minimum. Wasn't the minimum value 20? What was the highest?
The highest was
Oh.
45.
Oh, good, right? So what does this middle represent right here?
The median.
It kind of represent, yeah. Well, the median's inside here.
frequency and
Actually, you see
median.
this middle line right here?
Or the repetition.
No, that's a median.
Mhm.
That's the
Yeah.
median, right? Okay. Now, another thing you want to consider is this. Look at this one. You notice how this one is kind of like, this other graph is kind of like that? Okay.
Yeah.
Mhm.
Okay, so this same data that you see here is like over here, just placed differently. And where they're going to say, okay, this is your median, okay? They call this quartile 1. They're saying, okay, take 25% and go this way. Then take 25% and go this way. Now, why will this be important is that, okay, I think nobody, when they buy something, wants to know how much somebody paid for something, right? Like what's the most expensive, correct? Like if you're gonna sell something, you don't want to, well, sometimes you want to know what's the most expensive, but most of the time, you know, like if you're gonna buy something, you don't want to know what the most expensive is, and you don't want to know the cheapest, right? Why not? Why don't you want to know the min and the max?
I don't know.
Like let's say you're
Cheapest
gonna buy
could
a car. Would you want to know what the most expensive, like let's say you're gonna get a Ford Mustang. Would you want to know what the most expensive Ford Mustang sold for that year? Would that be important to you?
No, not really.
Not really, right?
Well-
Would it be important for you to know what the cheapest Ford Mustang ever sold that year?
No.
Yeah.
Just one in your price range.
If anything, you kind of want to know a range, right? What this
Well,
is
you can
exactly,
estimate.
that's exactly what the range is. Like if you take the median, right? You know, you want to know, okay, from the median, give me a range about how much more does somebody go this way? Let me change color. How much more does somebody go this way? Higher up, 25% this way? And then how much does somebody go this way? And then now all of a sudden, now you have a range, right? Now you have, okay, I should buy a car that fits between here to here. And then you know you're within a range. And then you know that that's exactly what you should be at. So this is where the power, sometimes the stats comes in, because then you could go ahead and make some important decisions. Okay, now let's go ahead and move on though. Okay, so Celeste, read what it says at the bottom.
Look one more time. What is the normal amount of time for a student in this class to do schoolwork per week?
Okay, so Marcus, now that you've seen data here, what would you say?
What is the normal amount of time?
Yeah.
From 28 to 32 hours.
Hey, there we go. That's exactly right. I love your answer, Marcus. Now you gave me the range. You gave me a very good range. And actually, she took it from right here, the box and whisker plot. Love it. 28, 38, about, right? So that's I like that. I like now you're starting to really think where the majority, because 50% of the students are actually doing it. We're right in that time spot, just like 50% is showing up here in that same range bar, right? Okay. Now let's move on to the next part. Okay. And Max, why don't you read the top part?
There is not one way to answer what is a normal amount of something. When we want to look at this in
Statistics.
statistics, we look at the range of the data, measure of center tendency, mean, medium, and mode, and the disproportion of the data from the middle.
Distribution of the data from the middle, known
Standard deviation, whatever.
deviation, right? Good. All right.
Deviation.
Okay, Marcus, go ahead and read what it says about range.
Range. We already talked about the range. The smallest number was 20 and the largest was 45. We can say the range is from 20 to 45, or we can find the difference and say the range is 45 minus 20, which is 25.
All right, good. Now, Celeste, why don't you go ahead and read central tendency?
Mean. Add all the numbers together and divide by the number of values.
Okay, so let's stop there, and there's an example right here, right? This symbol means add. So there's 24 values. So you see how there's 24, and when you add them all together, you get 774. So that in this case leads to 32.25. So we're off a little bit, Marcus. Remember we said it was going to be about 32.5. It's really 32.25. All right, good. All right, Max. All right, Maximus, are you still with me? Actually, okay, Max, go ahead and read median.
Add all the numbers together and divide by the number of values.
No. Median. Median's over here. Median.
Oh, that's me. Line all of the numbers up. Line all of the numbers up, smallest to largest, and pick the middle number. If there is even amount, find the mean of the two middle values.
All right, good. So these are the two middle numbers. And when you find the average of the two, it's still 32. Okay, good. Marcus, read the last one.
Mode. The individual value or values that appear the most. 28 and 32 are both show up 4 times.
4 times, exactly. Okay, good. Okay, now let's have Celeste. Let me scroll down and read what it says here as far as standard deviation. Well, actually, you really can read it, right? But right now that you see it, what is it saying to do?
Equal sign.
Yeah.
0 equal sign.
Basically, yes, and really what it is this standard deviation means like it's a formula to find out like how far you went. So Marcus, remember the values you gave me about the range? What was your range values?
Our range value was 28 to 38.
Yeah, 28 to 38, right? Ooh, 1 second. Let me change this highlighter thing and let's go to a pen. So 28 to 38. So what was in the middle?
What was in the middle?
Yeah.
32.
32.
Right? Okay, so what's the difference here this way? That's the difference this way.
Well, they're not the same, but I think they're supposed to be 25 each.
Well, it's roughly about, this is 4. So here saying it's 5.5. So actually the real range is this. You would have been more exact, more correct if you had told me, Marcus, that my range is 26.75 to 37.75. That's for one standard deviation. If you do 2, it will lead to this. That means it's like a little higher. That means it encompasses a little wider.
What did they get to 5.5?
They came up with this standard deviation equation in where they take the each value, right? Each value subtracted from the median, and then they square it. And then they divide by the number and then take the square root at the end. You notice how there's 3 dots right here? That means that this kept on going. The next value, remember how 28 showed up a few times?
Yeah.
It would be doing 28 minus 32.25 squared and keep on going, keep on going. And then that's how they would actually end up. Let me erase some of this with this 5.5. That's how they standard. They kind of like equate it all. They square it, and then they go ahead and take the square root of it to kind of give you back what you had. So it's just a way to get you a really exact number. Okay. All right, good. Let's see if there's anything else because I think that was it, but let's see. Oh no, there's some stuff here. Okay, so kind of going over, I'll just give you an overview. Dot plot, same thing. We went over that. Bar chart, same thing. And if you look at the histogram, okay, we kind of went over that. It shows up here about how it shows up the mean, the standard deviation, all the other stuff, right? Okay, so Marcus, read this next sentence and then tell me what you would answer.
Describe what the normal times are for the students from this class to do schoolwork each week. Use terms mean, median, mode, range, and standard deviation. So for mean, I would put,
Can we come
So
up with all this already?
yeah,
Yeah, actually, we did already. Yeah, so we don't have to do this because we did this already.
copy and paste.
Yeah, pretty much copy and paste. It was in the previous part, the previous page. Okay, so now let's go to the next page. Okay. And this one talks about making charts. Let's see. We made a chart, bar chart, histogram. And actually they wanted you to make it. Ooh, it's really good to advance. Okay, we're not gonna go so much into this because you start creating. If I have you create something, I go from the most basic introduction of learning to the most advanced right away. And so I don't want to get you there already. Okay, at least not yet. What I do want you to do is, let's see how the next page is. Okay, actually they went ahead and created it for you. With all that data, here's another example. These are test scores. And let's see what else we have. Because I think with one of them, same thing, dot plot, box and whiskers. Okay. If I want to go over anything with you on this stuff, okay, it's this. Okay. Notice all these test scores, right? All right. Now, when you see all these test scores, now notice how the stem and leaf plot, if you create it, shows you how most people got an 80, right? In the 80s range. And the dot plot does the same thing, just differently. And the histogram does the same thing, just differently. And so they really gave you two examples here. And then they also went ahead and show you how to do the measures of central tendency. The average, which is the median, in this case was 79. The median was 80, and then the mode was 80 and 85, okay, on those scores. So, our standard deviation in this case was 11. So, actually the one that would really show you really good standard deviation was gonna be our, did they give us a box and whisker plot over here? No, they didn't show it here, but it should be over here. Actually, I would say the box and whisker is a good way to see it. See if they show it. Actually, they don't show it here. Oh, it's right here. Now look at the box and whisker plot. So this one will really give you a range. So remember how we said the median was 80? All right. So the median was 80. And then the standard deviation means that most people went down to 70. Up to this one must be 87.5. So most of the class scored between 70 to 87.5. That's what this is guaranteeing you. And from there, that is, I would say that that's pretty much it. Okay. When you're looking at this, okay, how would you say about each one? What do you think each graph does for you? What would
It simplifies the data in a different way each time.
Yeah. In each time, right? Yeah, and you're absolutely right, Marcus. Okay, good. Anything else you want to share, kids, about the data and the graphs and how they're different? No? All right, good. Okay, so with that, thank you for joining us. All right. I look forward to, well, actually, more of anything, go ahead and make sure you write all these notes, upload them to me, and then everybody go ahead and say bye. We're going to go ahead and stop.
Bye.
All right.